Welcome to Initialization lecture. So in this lecture we're going to initialize our instance objects with a special method called init. And then we're going to examine object attributes. And then lastly we're going to use the inspect module to view a function or method's code. Okay, so we're going to create a very simple class here called class C3 colon. And it's going to have four methods. So def talk with self, speak, and code as our three parameters. Colon, and then self.speak equals speak, and self.code equals code, and then the last one is going to actually have a default value. So self.action equals a string of algorithm. Okay, so at the moment we only have one method here. We're going to add three more. And what this talk method is going to do is that we have to define what speak and code parameters are, and then they can actually be used, the speak in the code, in other methods, the three other methods that we are going to define. So def is going to be talking self colon print I'd like to talk about plus self dot speak, and then def programmer self colon print my code is self dot code, and then lastly def running self colon print, and this time I'll use the f string. In this case it's going to be only the formatting version available for Python 3.6 and above. It's an alternative to formatting, and we'll have this as, let's say, I ran my self.speak self.action. Okay, great. And now we're going to create an instance of our C3 class here. So d equals C3, run that. And now if I do d.tab, you can see I have my three methods: programmer, running, talk, and talking. Now if I do the talk method, which is the most important one, if I do the shift and tab in the parentheses here, you can see I have speak and code parameter. So we'll have that as Python and cool. Run that. If I do d.tab, you can see now I have action and code as the parameters, and I also have speak as well. So if I can check action, I've got algorithm. If I do speak, I've got Python, and if I do code, I've got cool. Okay, so I'll do talking method. Again, I'd like to talk about Python. D dot, it's going to be programmer. And I have my code is cool, and then lastly d dot running. I ran my Python algorithm. Alright, so if we take a look at the d dot action, we have the algorithm as the default value here, but we can change that to, let's say, decorator. Run that, and now if I do, I'll do it in a separate cell, d dot running. I ran my Python decorator. Okay, great. And I can change this as, let's say, JavaScript. And I'll put this as, let's say, slow. You can see that it's changed all the outputs here. So JavaScript, slow, and JavaScripts. Alright, so instead of using the talk method to define these parameters, which are the speak and code, instead what I can actually do is use that inside of the C3 class directly when we're creating the D instance. So we'll show you with the init method another class, and that's going to be called animals. So we'll have class animals colon, and then we'll have a doc string. This is a class of animals. And then just for demonstration purposes, we'll have some class attributes. So 100, B equals 245, and C equals 12,000. Okay, so now we're going to have the init method. And this is a special method. And you can tell it's a special method because it has two double underscores on either end. And there's many other special methods, but this is the most important one when you're using classes. So we'll have self as always, and then species, action, cute, and talk. And then we'll do self.species equals species, self.action equals action, self.cute equals cute, and self.talk equals talk. So no default parameters here in this case. And then we'll have 3 more methods of speak, self, print I can something, dot format, self.talk, and 2 others, so animal, self, colon, print, I'm a something, and I can something, dot format, self dot species, and self dot action. And then lastly, we'll just do eating. So self will be prints, and that's going to be self dot species is super hungry. Okay, great. And we're going to create an instance of our animal class. Let's say we'll have this as, we'll actually create a couple. So we'll do dog equals animals, and then we do the shift and tab, species, action, cute, and talk. So we'll have to define 4 parameters here. So I'll do, let's say, husky puppy, run, 2 billion, and let's say howl. I've seen a few videos of huskies howling. We'll have parrot equals animals. There's a type of parrot called lovebird. Fly 23 trillion, and let's say talk to humans. I think they can actually talk, these particular types of parrots, I'm not too sure. And then we'll do, let's say piggy equals animals, piglets, they're pretty cute, and then we'll have run like a dog, and let's say 3.4 gazillion, which is actually a word, and then we'll do oink. Okay, great. And then we'll do, let's say dog, okay, once we get the main dot animals at particular location in memory, same with the other 2 as well, of course, and piggy. Okay, and then we'll do some of the methods. So let's say I have dot tab. Okay, so you can see A, B, and C, which is our class attributes. We have our parameters such as action, cute, and species, and also talk. Alright, so I'll do, let's say speak. So you've got I can howl, dog dot animal, I'm husky puppy and I can run, and dog dot eating, husky puppy is super hungry. And similarly, you can get the same outputs with the other 2 instances, which are parrot and piggy, but I'll leave those. Okay, so let's say, for instance, I wanted to do dog dot species. You can see I've got husky puppy, but I can change this just like we did with the previous example with the algorithm to decorator. So I'll do Jack Russell, and dog dot, let's say we have talk, and that's going to be what, howl. So I'm going to do this as just woof. Okay, and then I'll do dog dot, let's say animal. You can see I'm a Jack Russell and I can run. Okay, great. And you can do the same with the other 2 instances as well, the parrot and the piggy, but I'll leave those. And let's say I was to instead take a look at the, just do the built-in Python method called dir, and then I'll do, let's say, dog. And you can see that I have this list here that contains quite a substantial number of these strings, but the ones that we're interested in is the ones that we define. So we have the attributes, the class attributes A, B, and C, but we also have the action, the animal, and the eating, and so on. And those are the methods, and then we also have the parameters here as well. And similarly, you can do the same thing with not just the instance, but also the class itself, as you can see here. Okay, so moving on from that, let's say I wanted to do dog dot double underscore. If you hit tab, you can see I have class here, and of course you get the main.animals. And if I were to do, let's say, double underscore, hit tab again, you do doc, you get this is a class of animals. And you can do the same thing also with animals. As you can see here, this is a class of animals. And if I just do dog dot double underscore dict, which is short for dictionary, you can see I have the parameters here, action, cute, species, and talk, and the values I've assigned to them. So you can actually, just like a dictionary, action, and you can change this to, let's say, jumping. Run that, and then if I do dog dot animals, or animal rather, I'm going to check Rossum, and I can jumping. Well, not really the best English there. Jump. Change that. There you go. Okay. And similarly, you can do the same thing with, let's say, piggy dot. You can see I have the run like a dog, 3.4 gazillion, piglet, oink. And I can do, let's say, talk. You can see oink. Alright, so just like with the dog and the piggy and also the parrot as well, instances I can do this with the animals class. So you can see here, but I have mapping proxy, and it's actually a tuple which contains a dictionary. So what you can do is, let's say, doc, this is a class of animals, and I can also do the same thing with, let's say, the attributes. So you get 100s, if I do B, I get 245, and if I do C, I get 12,000 here. Let's take a look again. You can see I also have my methods, so eating, speak, and animal. You have the dict, obviously, the init, special methods, module, which is, of course, is main. An alternative approach is to use the built-in Python function called vars, and this is going to give the same output as doing the dog with the double underscore dict double underscore. So we'll do dog, just like we had before. So if I do dog dot dict, you can see I have this output just like before. And likewise, I can do the same thing with the animals class. You get your mapping proxy, and you have it here as well. Okay, and I can actually, of course, just do the same thing of, let's say, doc, and you get your doc string here. Alright, so moving on from that, let's say I wanted to create a very simple function just for demonstration purposes. So we'll have def greet, no parameters, and print hey there. Alright, so what if I wanted to examine the code in this method here? Well, what we can do is import inspect module, and make sure you have this module in your Anaconda distribution. It should be in there by default, but if it isn't, go to your command terminal and then type in either conda install inspect, or you can do pip install inspect. Alright, so what I'm going to do is we'll have lines equals inspect dot get source lines, and then we'll put greet in, run that, and if I just do lines, I get something that's not terribly readable, but you can see there's actually all the code for this particular function that we've created. And what you can do instead is print dot, should be dot join, and then we'll have lines and 0, so indexing by 0, and you can see with the exact same output as what we had when we created the actual method, or rather is the output of the entire code for this particular function that we created. Alright, so what we can also do is the same thing with, let's say, dog dot, let's say, animal, and you get the animal method here, and I can do this directly with the class, so animals.animal, the exact same output, or I could have, let's say, eating, as you can see here. And similarly, I can do the same thing with, let's say I import a module like random. So random as rd, run that. And then I'm going to do, let's say rd.shuffle. It's going to be a rather large output. So you can see I have the output for the shuffle method from the random module. So you see the def, the shuffle name, then you see the self, x random equals none, and you've got some docstring here describing what it does, then you have some control flow, and you have 2 for loops here. Alright, so that concludes my lecture on the initialization method.